In this episode, we're going to talk about the difference between energy and power. And energy actually refers to the moving of electrons in an electric circuit, and is going to be based on a topic called joule. The joule then is the electrical energy required to move electrons, that is 1 coulomb of electrons, 6.25 times 10 to the 18th electrons per unit of time. In our case, we'll just use the second. So it's actually a rate. And across points of 1 volt, for this resistance then, we actually are going to say that we have 1 volt across it, and as we move 1 coulomb of energy, that's a 6.25 times 10 to the 18 electrons in 1 second, is actually what we're going to call a joule. So, in joules, we're talking about the actual energy being moved, and it's going to transfer electrons in the electric circuit. But it doesn't tell us exactly how much power is being dissipated by the resistance. So when we take this energy here, we're now going to have 1 joule per second that's moving, and we're going to call that the watt. One joule per second. And this is what's known as a watt. When we take this into Ohm's law then, to calculate the actual power dissipation of the resistance itself, we have 3 different formulas. Power then is now thought to be as a result of voltage times current. Power can be calculated as the square of the current times the resistance, and power can also be the square of the voltage divided by the resistance. All 3 of these in a DC circuit will give you the same value. AC it doesn't, but in DC circuits it does. So, we talked a little about what is electrical energy, how it actually flows in a complete circuit. It is calculated and called a joule, and then we can take this amount of quantity here of electrons that's being moved per second, and we'll call it 1 joule per second, and that's going to be equal to 1 watt.